Hello, my name is Nikisha Raybon, and I will be explaining or attempting to explain the process of how a nuclear bomb occurs. So, basically, uh, the main component of a nuclear bomb is nuclear fission. Nuclear fission basically occurs when an atom splits into two or more smaller atoms, most often broken down into what you call fission products or neutron bombardment. Um, so basically, with nuclear fission and with a nuclear bomb, whenever there are really heavy objects that are released with heavy elements, I'm sorry, that's exothermic reaction. And with the when an exothermic reaction occurs, there's going to be lots and lots of energy that's released. So, an example, an atomic bomb, aka nuclear bomb, is basically a nuclear weapon that uses the energetic output of nuclear fission to produce massive explosions. Hence, the atomic bombs slash nuclear bombs that were dropped on Hiroshima. I always mess that word up. Hiroshima, and Nagasaki back in 1945. So those bombs were basically made up of uranium. Uranium is an isotope that can sustain a fission nuclear chain reaction. Um, and with an atom such as uranium 235, the uranium splits into two smaller atoms called fission fragments plus more neutrons, and it can definitely be self-sustaining. It can be self-sustaining because it produces more neutrons with the speed required to cause new fissions, which basically creates a chain reaction. So the uranium 235 content of the weapons grade uranium is generally greater than 85%, um, though inefficient weapons deemed weapon usable can be made of 20% uranium. So um, the very first uranium bomb, Little Boy as they called it, was the bomb that was dropped on Hiroshima in 1945, which was it used about 64 kilograms of 80% enriched uranium. So that's pretty massive. Um, the implosion method, which is more sophisticated than a gun method, can only be used in the fissile material in is plutonium. So plutonium was the bomb that was made up of the bomb that dropped on Nagasaki 3 days after the bombing of Hiroshima. So with that one, that was uranium 236. So which undergoes fission, releases further neutrons, that kind of continues the process. So the uranium atom can basically split any one of dozens of different ways, as long as the atomic weight adds up to 236. Um, the immediate energy released per atom is about 100 million electron volts from that bomb. Of the energy produced, about 93% is the kinetic energy of the charged fissile fragments flying away from each other, being repelled by the positive charge of their protons. Um, the initial kinetic energy imparts about an initial speed of about 12,000 kilometers per second. So that's pretty fast. That's definitely pretty fast. Um, what else could I add? What else could I add? Um, So with reactors and the fission, the energy released from nuclear fission can be harnessed to make electricity also with a nuclear reactor. A nuclear reactor is a piece of equipment when nuclear chain reactions can be controlled and sustained. The reactors use nuclear fuel, most commonly uranium 235 and plutonium 239. Yes, plutonium 239, not 236. So the amount of free energy in nuclear fuels is far greater than the energy in a similar amount of other fuels, such as gas. And in many countries, nuclear power is seen as environmentally friendly alternative to fossil fuels, which are non-renewable and release large amounts of greenhouse gases. So, and with the chain reaction, when you have large atoms such as plutonium 239 and uranium 235, when it absorbs a neutron, it can undergo nuclear fission. The nucleus can split into, like I said, two or more lighter nuclei, releasing kinetic energy, gamma rays, free neutrons, and part of them may later can possibly be absorbed by their fossil atoms and trigger further fission events, which release more neutrons and so on. So, which is in the end called a nuclear chain reaction. So, hope this basically answers the assignment. All right.